So for the next example, we're going to look at the fundamental theorem of algebra. So every complex polynomial function f of x of degree n greater than or equal to 1 has at least one complex zero. Now remember, these include any real numbers. Okay, so any real number is also a complex number. The conjugate pairs theorem, if we find a zero at a plus bi, then its conjugate, a minus bi, is also a complex zero. So, for example, if we have a polynomial function with a degree of 5, whose coefficients are real numbers and has zeros 2, 4i, and 3 plus I, find the remaining two zeros. So if we have a degree of 5, it has to have at least 5 zeros. Okay, so the real number here is 2, and our complex numbers are 4i and 3 plus I. And based on this conjugate pairs theorem, we know that if 4i is one of the real numbers, then negative 4i has to also be one of the real numbers. And if 3 plus I is a real number, or complex number, that's a 0, then we also have to have 3 minus I. So our real zeros for this problem would be 2, 4i, negative 4i, 3 plus I, and 3 minus I. So those would be all of our real numbers, or zeros, I'm sorry. So in our next example, reminder of the fundamental theorem of algebra. So now we have the linear factorization theorem. So if c is a complex zero of a polynomial function, then x minus c is a linear factor of the polynomial. So this is how we put those real zeros into a factor form. Okay, so what basically we're looking at, so this number would be x equals 2i. So then to move it over, we would subtract it and we would end up with the factor x minus 2i. And we would do the same thing with x equals negative 2i. That would factor to become x plus 2i. And then just as a reminder, with the factor x equals 1/3, you would multiply both sides times 3. And from there, we would end up with 3x equals 1. And then subtract 1, so 3x minus 1 would be our factor. So the factors for these zeros would be x minus 2i, x plus 2i, and 3x minus 1. Let's look at the second example. So let me get these out of the way. Okay, so for the second example, this would become x equals 2 plus I. We would first, we would move it over. We would keep it together, and you might see it listed as x minus 2 plus I, but they may also take and rewrite the signs on some examples as x minus 2 minus I. The other one would be x equals 2 plus I, or not 2 plus I, 2 minus I. And it would become x plus 2 minus I. And if they simplified it even more, on an answer to, say, a question, it might be x plus 2 minus I. And the last one, x equals -4, we would know that means x plus 4 would be our factor. So our factors for this problem would be x minus 2 minus I, x plus 2 minus I, and then x plus 4.